This then is water. You're gonna leave it stir, make it dissolve quickly. If we fill the line here, just 100 milliliter solutions. Okay, it's done. Show the solvent. Now I'm going to assemble everything. Basically, this is the sample we're using. I have a tweezer, maybe it's easy to show. This is a blank GDE electrode. GDE, the full name is called the gas diffusion electrode. Basically, it's some carbon fiber. You can see. We coated on this side. This is the microporous side. So the back side and the front side is a bit different. The back side is just some carbon fibers. We call it toilet paper. So this is the front side. So we coated the copper. We coated the copper on the top of the microporous side. So it looks like this color after coating copper.
You can't really see the difference.
Cannot see difference?
No, not.
Yeah, maybe the
not
camera.
Good light, yeah.
That's fine.
Yeah.
I can show them picture after that.
Yeah.
Like that?
This is my phone.
Oh, your phone.
Okay, it's recording.
This is the whole thing. What's that? This is the copper side. A little bit difficult to have this course in video. I feel very difficult.
Yeah, it's just not the same for the students
yeah,
either.
it's very difficult.
But it's the best we can do.
Yeah. You also haven't seen my cell before. No, not really see the real one.
Exactly, yeah.
It's super simple stuff.
Was this also what Sebastian worked on?
Yeah, so far it's good, but their disadvantage is the voltage. The cell voltage is slightly high. If in this case, because you have a very thick layer of electrolyte, which will consume a lot of voltage and electricity.
Because you have what electrolytes are?
I use potassium bicarbonate. I also can use QH.
Yeah.
But for safe reason, this kind of experiment I use bicarbonate. Yeah. QH you.
But you have both electrolyte and both catholyte and anolyte, right?
Yeah. Catholyte and you will use same electrolyte. Of course, we also can use different one.
Yeah.
You have bipolar. I have bipolar membrane, but in this training, I just use the inactive membrane. Yeah.
I'm just gonna zoom in.
Yeah.
Now that we have it. Yeah.
Yeah.
I mean, I'm just gonna record everything, and then afterwards you can
Yeah. Sure.
take
I can
what.
edit it.
Yeah.
That's fine. I know that's it. My first time to do this thing feel a little bit weird. So this front side. From the camera cannot see difference, right?
No.
Oh, that's
A
fine.
little. Yes, it can.
Little bit.
Yeah.
Little bit. This is the copper catalyst.
You can't see that it's copper color. Well, a little bit. It does look. It doesn't look all black. Yeah. I mean.
Yeah, that's what we. There's nothing we can do. That's it.
Yeah.
This is membrane already immersed in the dynamic water. Maybe later put my membrane. This is a little bit. I first fill the electrolyte. One chrysolite, one analyte. Already dissolved. See? Don't test the liquid products. I don't have to be so precise. Normally I have to use some this thing to measure how much I fill in.
Ah.
Otherwise you cannot. After that I also have to measure again. Otherwise you cannot know exactly how much electrolyte.
Okay.
you have.
Yeah. That makes sense.
Because every time after experiment the electrolyte volume will be changed a
Yeah.
lot. Now start the membrane.
And why are you not measuring liquid products?
In this,
Yeah.
there's not enough time, you know.
Okay,
Only 3 hours experiment. They cannot learn the SPLC merit.
No. Yeah.
Just do the simple experiment. This membrane. Yeah, looks like it's already hydrated. This side actually is a counter iridium oxide coated on GDE. So the black one inside. It's the iridium
Can
oxide.
you turn it to the light a
Yeah,
little bit?
maybe. It's not very good, right?
Yeah, it's not easy to see.
Let's see. This old camera from the last century.
Yeah, exactly.
Gasket, immobilize the membrane. Then this is the chrysolite chamber. So this is the reference we use. The guy. Look at that. Put the catalyst. This is the catalyst side. Catalyst side contact with the electrolyte. That's pretty quick.
So you flow in catholyte that has
Both sides they will flow. Chrysolite, analyte will be cycled.
And then the CO2.
CO2 goes to the gas chamber. This is the gas chamber.
Ah, okay, that's the gas chamber.
Just the gas chamber and the electrolyte just separated by the GDE between. So in that case, the electrolyte will not flow. You can make the interface between your catalyst, gas, and the electrolyte. So, yeah. you have efficient gas supply. Reduce the mass transport limitation. I can make it a little bit tight. This is a homemade cell. It's super cheap. Only, I think, less than $1,000.
Really?
Yeah.
Is it like?
Very cheap. You see the configuration is super simple.
Yeah.
It's very cheap, but it works so far.
But how is the gas? It doesn't have like this flow. Usually the gas.
Flawed.
You know, this pattern that the gas flows in. Does it have that? This cell? You know, like. You know, when it does the flow, it flows in like this in some of the other cells.
You have bubble electrolyte. You have a cell.
I hear you bubble.
No, we don't bubble.
No, you just have a.
Yeah, you have a separate gas chamber. The gas will not normally the gas will not go to the electrolyte side because the GDE is there.
Yeah,
it's
hard.
them.
Yeah, it's hydrophobic. Yeah.
Of course, if your GDE is slightly damaged, you may have a slightly gas trap penetrate, but the most time is just stay in the gas chamber. After reaction, the gas chamber. The some gas products also transport through the gas chamber, vented out. Yeah. Okay, I'm going to assemble it. I'm going to connect it with the real stuff.
But the one that Gaston has.
Gaston has is MEA. Is different. He doesn't have the capsulite. Capsulite is humidified CO2 directly.
Right.
So in that case, yeah, I don't know why he cannot go to the very high current density. Will be stopped. Lot of noise. Also, if we go to the high current density, there will be a lot of hydrogen evolution instead of CO2 reduction. Also, that one, if you want to assemble that one, you will take a lot of time. Maybe sometimes whole day, even
to assemble it.
Yeah.
To assemble it.
Yeah, because that one sometimes you have a lot of problems.
Okay.
Yeah.
So you have to assemble it and then disassemble it if it doesn't work.
Yeah, it's annoying. I know.
And that's because of what? The contact?
Because the contact is make a sandwich structure is very difficult. Even have a little bit of change of the gasket, you will make a leaking
the spacing between,
contact badly. It's so fragile and difficult to run. This one I can do the same experiment like 3 times per day.
Wow.
at least.
Yeah.
Even more.
Yeah.
So it's super quick. Because I still like it so far. Let me check. Okay, everything's fine. We can first recycle the anolyte, make sure the membrane is white. If the membrane is dry, it will die. Cycle, see, started cycling. Isolite.